Alright, this is my second try at a video for this application problem. The last one was almost 11 minutes long and I felt like that was a bit excessive, so I'm going to try not to talk so much this time. I did pick the hardest problem I could find on this particular application because I want to show you the most difficult one so that the other ones hopefully seem a bit easier. So the area of a triangle is 1/2 times the base times the height. We've got our base here, we've got our height here. Make sure that the two measurements you're using for triangle is the base and a line that is perpendicular to that base, which this height is. So whenever you have a formula like this, the first thing you're going to do is just plug in the values that you know. So this is going to be area is 1/2 times the base, which is 15√70, times the height, which is square root of 35 plus 4. Now, because this height is a two-term polynomial, I am going to have to do some distribution. And I've got two things that are being distributed into this. I've got this 15√70 that needs to be multiplied by both the square root 35 and 4. I've also got this 1/2. There's several different ways you can approach this. My habit is to kind of leave that half waiting until the very last possible step. I am going to go ahead and distribute this now. Now, if this was a perfect square radical or something that I knew could be simplified, then I would go ahead and do that. But in this case, 70, nothing pops to mind immediately, so I'm not going to worry about it right now. I'm just going to go ahead and start distributing this 15√70, meaning I'm going to say 15√70 times the square root of 35 and then 15√70 times 4. Please, please, please do not forget about that 1/2. Make sure he gets carried down on each step. So when I'm multiplying radicals, the coefficients get multiplied. Well, the coefficient here is a little understood 1, so 15 times 1 is 15. And then 70 times 35. Pull up your calculator and let's see, 70 times 35 is equal to 2,450. So that is the square root of 2,450, which is a big scary number, but we're not nervous. It's going to be fine. When I multiply 15√70 times 4, I only have a coefficient here, or a constant, so 15 times 4 is 60, and then I've still got that √70 floating there. All right, what I'm going to do now is try and simplify these radicals if they can be simplified. So I'm going to do that with my good old factor trees. That 1/2 again is still there. 15 is still there. And actually, I don't need to write that just yet. I'm going to erase that. I'm going to just start my factor tree right here underneath this 2450. There's lots of things that this is divisible by. The quickest thing that pops into my head is because I have a 0 here, I know it's divisible by 10. And 2,450 divided by 10 is 245. If you're not sure about that, then again, there's no shame in using the calculator. 10 then goes to 2 times 5. 245, I know it's divisible by 5, but I honestly don't know what else is there. So I'm going to say 245 divided by 5, and I get 49. Yeah, definitely didn't know that. So 5 times 49, and then I've still got my 2, I've still got my 5, I've got this other 5, and 49 is 7 times 7. So when I'm looking for pairs here, I've got a pair of 5s and I got a pair of 7s. So that means when I rewrite my area, I've still got that 1/2, I've still got that coefficient of 15, but now I've also got a coefficient of 5 because the square root of 5 times 5 is just 5. And I've got the square root of 7 because the square root of 7 times 7 is just 7. Underneath this radical, the only thing that's left behind is that poor sad little 2 that didn't have any friends. And then over here, let's check and see real quick if 70 can be simplified. 70 is definitely 7 times 10. And 7 is prime, so there's nothing else I can do. 10 is 2 and 5. So I don't have any pairs there, which means I get to just keep this as 60 root 70 and then close my parentheses. All right. So then my next step is going to be to actually multiply these little coefficients here. Again, I still have my 1/2. I know you don't like to write, but just take the time to do it. 15 times 5 times 7 is equal to 525. Still got that root 2 plus 60 root 70. And now I finally get to distribute this 1/2 into my sum because everything's simplified. I've done all I can do, and I'm going to go ahead and multiply everything by 1/2. Multiplying by 1/2 is the same thing as dividing by 2. So when I say 525 times 1/2, I can write it as a fraction, like this, and then have my root 2, or I can put that in the calculator and get a decimal. It really does not matter to me because we're going to be estimating in a minute anyways. 1/2 times 60 is 30, because again, it's the same as dividing by 2, and I still have that root 70. Now, if you are actually doing a real-life application problem where you need the area of a triangle for, say, figuring out how much wood you need for building a giant monument of a triangle, I don't know, or paint or whatever, then going to Lowe's with this measurement, not going to make a whole lot of sense. They're not going to know what you're talking about. So it's good practice to have this perfect answer here, but also to just, for the sake of completeness, give an estimation as well. So for this, I need a calculator that can actually work with square roots, and my little computer calculator can't. So I'm going to type this in exactly as I see it there. It might be easier to put this 525 root 2 as a decimal. So I'm going to do that real quick. You can put it in the calculator, 525 divided by 2, and you get 262.5. So then in my calculator, I'm putting 262.5 times the square root of 2 plus 30 times the square root of 70. You can see I've got it just like that. Let me see if I can get it. There you go. And it gives me this crazy decimal here, 622.2290681. I'm not writing all that. I'm going to round it. I tend to just round things to the hundredths place unless I'm told something different. So 622.229 would round to 23 hundredths. So if I were trying to turn in a perfect paper, I would give this answer because this is the exact measurement with no rounding. This is the measurement that probably is more meaningful to anybody who's actually trying to use this measurement for something. So they're both good pieces of information to have. All right, so I got the video in about 2 minutes quicker. You're welcome. Let us know if you have any questions, and please, guys, don't be afraid of big numbers. They work the same as the little ones. Bye.